Hello, and thank you for joining us today for our webinar on supercharging business applications with predictive analytics. Today's presentation will be brought to you by Drew Minkin, our Director of Analytics Platforms and Partners, and Jamie McLennan, our Chief Technology Officer. For today's session, we've set aside some time at the end for questions. So if at any point during the presentation you do have a question, please use the question pane. It's located in the GoToWebinar control panel on your screen. So without any further ado, I'm just going to go ahead and hand over the microphone to Jamie, and he'll get us started. Thanks so much. Jamie?
Hello, everybody. Hi, Jennifer. Thanks for the
Good
intro.
morning.
Today we're going to...
Jamie, could you adjust your microphone volume just a bit?
Sure.
Thank you.
Is that better?
That's a little bit better. Thank you.
Okay. So, hello, everybody, and sorry for that technical difficulty. Today, Drew Minkin and I are going to talk about supercharging your apps and adding predictive analytics, how adding predictive analytics to applications can make a difference in the actionability and the usefulness and the appropriateness of your applications, but in making decisions and bringing data to the point of decision. I'll give a brief intro on saying why you should do this and what it means to do this, and then Drew is going to walk us through a few use cases on what supercharged predictive apps can look like, and then we'll have a short discussion on how Prediction Insight makes predictive analytics for applications easy. So why supercharge your apps? So typically, the apps that we use on a day-to-day basis are all data-driven applications. And a good application which which exemplifies a typical data-driven application that I thought about is actually my power bill. My power bill comes to me every month, and it shows me how much power I've used in the past. It shows me my electric usage and my gas usage, and it actually is, as far as an application is concerned, compared to most applications, it's actually very actionable. I pay my power bill every month, so I actually take an action based on this application I get. However, there's a lot of things it doesn't tell me. It tells me how much power I've used, but it doesn't give me any idea on how much power I'm going to use next month. It doesn't tell me, even though it does tell me, and it's very nice in how it shows me, how much power I've used this year compared to last year. It doesn't give me any indication of why there's a difference. Maybe the temperature got higher or lower, but is that really the impact of why I use more gas or less gas? Is it because I bought a gas grill? There's a lot of other pieces of information that can't be derived just by looking at historical data. Predictive analytics actually gives you a design of your application, which is actually derived from the data rather than designed what people might think an application should show. So my power bill shows me my current usage, it shows me my past usage, and any insight that I want to gain from looking at those pieces of information together are really driven by my instinct. And only on the actions I can take are only driven by my instinct. And it's because a designer decided to put that data together, and I had to figure out what to do with that information. Now, a predictive application would actually tell me more things which are relevant to me. It lets me make the decisions based on patterns in the data which are relevant to me. It'll let me say, based on your past performance of your data usage, of my power usage, this is the power usage that you might have in the future, and therefore you can make a decision to change it if you want to. It would allow me to do things like say, based on all the factors that we have available to you, this looks like this is the main reason why your power usage got increased or decreased. So I can actually make changes in my business and in my lifestyle to have an impact that that will make a difference in the future. It allows me to do things like change certain factors in my business or in my usage of power to say, what if I did something differently? How would that impact my power bill in the future? And all those different kinds of aspects of producing actionable results and giving me more information which is more specific to my particular situation are the kind of supercharging you get by adding predictive capabilities to your application. Now, for the rest of this this presentation, I'd like to turn it over to Drew Minkin, who will actually explain specific use cases which are more business-oriented, which will describe exactly how supercharging your apps through predictive analytics could look in a variety of cases. So I'll turn it over to Drew, and it's all yours.
Thank you very much, Jamie. Thank you very much, Jamie. So the first use case that I'd like to speak about is financial services. And while this may not seem to be the most likely place to talk about predictive analytics, it is something where I think it's very valuable to discuss. And especially with recent events, I think that it's a very cautionary tale about some of the challenges, even in places where predictive analytics has been well established. For example, anytime that you're applying for a loan and you see a credit score, that credit score is essentially the product of some predictive analytic model. So you could argue that we're kind of surrounded by these types of models already today. But by the same token, a model by itself is a wonderful piece of work, but it's about how quickly you can get that to the point of decision, and beyond that, it's also what you need to do in order to make sure that that model is current and that you are not lagging in your decision making based on changes in the outside world. As a very specific example, there was an article in Wired about the model that destroyed the American economy, where there was a theory, and albeit I would not say it's definitive, but there is certainly evidence that there was a complex need to be able to build a predictive model in order to be able to price mortgage-backed securities. And there's a lot of work that was done by very smart people to build these predictive models. But there was an asterisk before the business signed off on it and started making applications and making large investments and risks based on this model. And that was that the model itself is dependent and only going to be useful so long as there's a stable population, and so that we're expecting that there's only a few foreclosures or a few people getting late on their payments, and that if you're not keeping track of how much things are changing, you can't necessarily have the model react properly. And so it's a case where there might have been too many decisions without enough of the reflection of the new state of affairs, and a model desperately needed to be refreshed that some people ended up paying for it directly or indirectly there. So this is not just theoretical in this space. This is something that even the most well-intentioned and most seasoned professionals can sometimes fall prey to the idea that a model itself is sort of a monolithic piece. And part of our vision is that when you think about metrics and your business analytics work, you have a vocabulary and you have sort of a culture of being able to talk in those terms for data-driven decisions. And so our goal is to try to bring those types of technologies into the mass groups of analysts instead of it just being sort of an island of data scientists or statisticians that understand these things, so that there's more of a corporate culture around predictive intelligence, or the combination of predictive analytics and business intelligence. But getting back to what we're looking at today, there are very real things from a perspective of outreach that can make a significant difference where predictive analytics can come into play. And so some of those areas where it ends up being an issue are making sure that you have this quick reactions to changes in the market. And also particularly when it comes to any financial service, whether it's retail banking or investment banking, there's usually money doesn't just kind of sit by itself. You end up usually doing something with it, and you're expecting that that you've got some stability in your projections that are making. So it can be very critical. And if you think about from a retail bank scenario, which is what we'll be looking at in a moment here, while there may be loan activity that is the most profitable piece, you also have to remember that if you don't have enough reserves from other accounts that aren't being loaned out, you can't necessarily cover those loans. And so that's something that ends up kind of driving home that while banks may spend a lot of time worrying about the loan failures and credit risks and stuff, that unless you have a strong base of customers that are regularly doing your deposits and regularly getting other financial products, that you may not be able to do all those types of loans that you're looking for there. So what I'd like to do is introduce you to our first use case. And again, there's a wide variety of applications that can implement predictive analytics. In this particular case, I'm using what we would consider the simplest one, and this is a reporting services-based application. So behind the scenes, what we've done is that we have automations with integration services to be able to take scores from predictive models and then add them to a database that we can then look at for a reporting scheme. So in this particular case, we're focusing on my home state of Texas, and we're looking at a particular performance metric for a retail bank. In this case, it's capital adequacy ratio. And essentially what that is the amount of, the percentage of money that you have on hand that people aren't writing checks on and they're just in deposits versus what your actual obligations are for loans. And so this is a very critical factor of understanding the stability of banks. And in fact, when you have a run on a bank, it's usually because that adequacy ratio has gone too low, and so that's when the FDIC has stepped in a lot of cases. So long story short, the lower the number is, the more of a problem it is, because it means you really can't cover your obligations there. So if we look at the panhandle of Texas, we can see that here our capital adequacy ratio is pretty low compared to the rest of the state. So let's dig in and see what's going on here. So as a default, we know that because kind of in the pyramid of transactions that our checking accounts are sort of the meat and potatoes. It's not a very exciting part of the financial world, but it is something that is very critical for being able to maintain those capital adequacy ratios. And so this gives us an idea that we can see based on a risk model of the assessment of how often people are leaving the bank, or your attrition risk, if you will, that we have a lot of red areas, which essentially means that we are seeing significantly higher levels of attrition in order to be able to, that are impacting our reserves here. So while there's certainly, you could do an entire demo and modeling on trying to understand what are the root causes of that, as Jamie had mentioned. What we're going to focus on is more about how you can react to this scenario, because essentially if you're not having the money coming in, then you need to either be able to get more money from your customers or make sure that fewer of them are leaving. So you've got a couple actions already just from an analytics view in this case. So what we're going to do is take a look at our customer base and try to understand where we have opportunities in order to be able to increase our capital adequacy ratios in this area. So what we're rendering here is a report that shows for the entire region examples of customer composition. And so there's a lot going on here, but again, keep in mind that when you're making these decisions, we try to give each model a lot of, it's very easy to be able to put in production. So it may look like it's very complex to be able to get these types of models, but we'll be showing you later that it's pretty easy. But the point is here is that we have essentially a decomposition of the population where we've been able to do some previous analysis, and we understand that there are actual segments in the market that do act differently than each other. And so that's where these names like banking near work, thrifty check writers, et cetera, has come from. We'll talk a little bit more about how we arrive at those type of things in a later use case. But the there's another aspect of models that are in here. So you could look at essentially each recommendation as being a combination of one model itself that was used to generate the propensity for this being the best product to recommend, but there may also be other models that are factors in that decision. You can see at the top here that overall, if you look at the customer value, which is essentially it's a proxy for the estimated profit for a particular customer, you know, how many fees you're expecting to get, how much interest you can give. And we also have an attrition risk. So that tells us from another model how likely a particular customer is to potentially be leaving. But, you know, at this point, we're primarily focused on trying to get as much income as possible because the capital adequacy ratio pieces. So what we're going to focus on is the customers that have a propensity for mortgages, because mortgages are the most profitable banking product. And that may explain a lot of things historically there. So let's take a look and understand. We're going to focus on the casual banking customers and the mortgage propensity for the best product. And before we actually contact these customers to try to sell them on a mortgage, it helps to understand a little bit better where they're coming from, because when you make that touch, you want to make sure that you optimize that customer touch as much as possible, because it may not just be the product that is best suited for them, but you may want to be able to address other issues here. And so the more information that you can empower your line of business applications with in order to be able to take that guesswork out of where a customer is coming from and what are the things that I need to discuss, then the better traction you have with the customer, the better your loyalty is going to be with that customer, and also, more importantly, the more precise you can be about accomplishing business goals you're looking for. So in this particular case, what we have is the email addresses and phone numbers for many customers. We also have a purchase probability. In this case, it's for mortgage products. We also have an estimated profit, so we know what our customers that we're making the most money off of. And we also have an attrition risk. So, for example, you know, we may decide that we're certainly going to go after the people that are most likely to buy first. So we'll go ahead and change that. And then we can see here that this person is also a very high-value customer, and they don't own a home already. So that helps guide the messaging that you'd want to talk to that particular customer for. But as an example here, if we look at your attrition risk down the line here, we have a 21% chance of attrition. And so depending on the business cases, you may decide, okay, maybe it's best if we talk about an incentive to that particular customer in order to try to make sure that they're happy, or just do sort of a high-touch move in order to embrace them better and give them the warm fuzzies, if you will. So again, we've taken from the macro view of business analytics and weaved in a large number of models in order to be able to bring you to a state of empowering your line of business to make better decisions there. So what I'm going to do now is flip back and show you a little bit about the model that's behind this particular scenario. So this is a sample of a model that we've created. This is using the prediction viewer that shows sort of our thin client. And so you can see here that we can, and this is important for being able to add that social element to predictive analytics, because the more crosstalk that you have between business people and your analysts and your statisticians or whoever's in the role of predictive analytics, then the better you're going to be able to accomplish your business goals here. So we can certainly post comments, and we also have a wide variety of different views that we can look at. And so, for example, here we have the predictor view, which gives you an idea of the scenario for what are the contributing factors for a particular estimation for profit. And so we can see here that we have a different cluster than we were looking at before that we can use. And by varying it, we see that in this particular case it doesn't change much. But if we look at debit spend profile, it also doesn't change much. But this gives you an idea of the complexity that we simplify, because you can do role playing from here on the modeling itself. So when we look at financial services here, the three main things that we want to try to accomplish are increasing customer loyalty, anticipating the changes in the market and behavior early with forecasting and other types of estimations, and also getting more sales per campaign. But beyond financial services, the types of applications that we're looking at building with these propensity scores can go beyond financial services here. So customer attrition is certainly something that is not limited to financial services. Neither are enforcing customer loyalty. But those are places where there's a lot of very rich data that you should be collected, either from demographic information or web history, what have you, to be able to build attributes and build these models. But a similar type of approach can also be used in manufacturing to be able to try to understand when you can expect there might be a failure or a need for maintenance on a particular application, so that you can be very crisp about the actual states of delivery mechanisms for being able to schedule the right people at the right time, and hopefully be able to not only decrease costs but also increase your uptime. And a similar mechanism from a modeling perspective is also available for, you can use these similar techniques for finding prospects from lead lists. So very simple modeling concepts that are that can expand into a wide variety of business use cases. And so beyond financial services, we are now looking at another type of use case, and this one is a little bit more complex. And this has to do with large-scale manufacturing. And I put this picture up here on the Deepwater Horizon part just to be able to show kind of a cautionary tale of a scenario when, if you don't have enough instrumentation and you don't understand where problems may potentially occur, that you want to dig into the application, dig into the scenario better. So the main thing is that we want to make sure that we have a very robust system for being able to bring in a wide variety of models and be able to make sure that even in something as fast-paced as manufacturing, where things may be flying off of assembly lines or sensors may be firing at very, very rapid speeds, that we can take, even in those very, very complex systems, a way to be able to capture data and be able to understand what's going to happen and be able to be prepared for those type of scenarios in the future. So, traditionally these have been a challenge. At one point it might have been data collection, but nowadays the main thing is that there's really too much data being collected, and now we need easier ways in order to be able to build models for those scenarios. So complex event processing is something that is a new class of applications, and this is something that we've worked with Microsoft Stream Insight for, but what distinguishes it from other large volumes and kind of big data workflows that you may have run into are that there's a continuous processing of event streams. Typically, when you're looking at Hadoop, you're looking at large batches, large files, but things that may be aggregated from other sources, then you're looking at them from a historical perspective. And usually those are all normally going to be text or something that can be looked at as tabular, whereas when you look at complex event processing, your inputs may actually be sensors that are on equipment. And so it may be something that's just used to going to a monitor just to show whether it's dropping or green, yellow, red as far as those type of expected levels. But the trick is that a lot of times you can't just focus on one metric or one bar to understand what's happening in the system. You have to understand the relationship between them, and sometimes the relationship may be very difficult to understand on the surface. And so that's one of the beauties of predictive analytics, is that it can take large numbers, hundreds and hundreds of columns, and distill down to the dozen or so, a lot of times, that typically are factors in finding out a pattern in what's happening there. And again, on the complex event processing side, different than a lot of other applications, is that the idea is that you want to be able to know from a query very quickly what's happening, because you want to make sure that you've got the snapshot while the data is in motion, and you also want to make sure that you can act while everything is in motion. So speed becomes a very, very critical piece of that type of approach. So when you look at predictive analytics and supercharging applications that need just that type of monitoring piece, you normally look at them in a tiered fashion. And there are different scenarios for different types of models that are appropriate at those types of levels. And this is not to say that you can't mix and match, but in general, these are the type of breakdowns that we see between work that's happening to understand whether there's smoke first and then there's fire, as an example, or whether there's something that you need to ultimately route someplace potentially, and then have a larger application or a more complex model look at a deeper insight from that perspective here. So again, these are, while manufacturing may be the place that we're talking about here, I just want to point out that it's not just manufacturing where this can be very important. One example that we have in healthcare is that we've been discussing with a university here a model that they have to be able to predict within 48 hours whether you're going to have a heart attack or not. And so you can imagine that that's a very, very useful model, but the challenge is that it looks at dozens of different variables that are in all different places of the hospital. So it looks at prescription data, it looks at nurse checks, it looks at lab data. And so anytime any of those change for any patient, we'll have to do a rescore and another rescore and another rescore. And so you can see that in a large hospital that the line between what looks like a traditional application and what looks like a complex event processing application can end up being very blurred. And so, the manufacturing case that we've done work with here is something that is very poignant, but again, it's not limited to that particular type of scale of an application. So what we have here is that we actually did some work with a major manufacturing group, and so what we did was we had built an anomaly detection system for all intents and purposes. And so the idea was to be able to automatically be able to output scores to show whether or not we were entering an anomalous state, and also make those alerts be available to operators that could then be able to intervene on their behalf. So just to give you a little bit of insight, I'm going to show you some of that model. And so you can see here that what we've done is that we got samples of 5-minute, in this particular case, polls of 177 different sensors that they had. Some sensors were coming in at millisecond level. Some of them we only got readings from them every 5 minutes. But we built a model and we could see that essentially there were really 9 states of behavior that we could see within the model itself. So as an example here, I'm going to go ahead and show the segment network. And again, what this is showing you is the differences between different operating states of the pump in this particular case. So you can see here that we have a wide number of relationships with them, but we normally try to focus on the strongest relationships. So as we go down here, you can see that one of the strongest relationships is between 3 and 7. 3 here and 7 here. But from a population standpoint, you can see that the darker the cluster, the larger the population here. So you can see that these don't happen very often, but they are deeply related here. And so what we found was that when we looked at sort of a decomposition of the failure that they had, is that we plotted the segments themselves against time And we saw that essentially there were these segment 3 and segment 7s that did not happen any time before the failure. But we could see that after the failure itself that they were consistently happening with very few exceptions there. So this is something that was sort of the beginning of other models, and then we basically looked at a root cause of what was different about those two segments. We built other models so that we could actually go back and actually detect problems weeks before the problem would occur. And so, that was a very interesting approach to be able to not only understand where there was a difference, but also be able to get to a root cause analysis through additional modeling there. And so with this type of application, you can build very complex models and also very complex rules as far as how you bring together these data feeds in real time. And while we were only responsible for the predictive analytics part, we had to expose our models so that they could, in a very short period of time, be able to get a prediction back from our server here. And so, we were very proud to be able to get a 4 millisecond latency for, one round trip. In future applications, we're looking at things.
Hello, Drew. I think we might be having a small technical difficulty here as the audio seems to have stopped. If you could all please be patient, we'd greatly appreciate it while we try and get Drew's audio back online. Give us just a moment, please. Thank you.
Sorry for that technical difficulty there.
Oh, it's good to have you back, Drew. Thanks, everyone, for being patient.
Sorry about that.
No worries.
Just to review there. So, we saw demographic personas coming into place in the financial services scenario, where we saw lots of different ways to divide the population into different groups. We used a similar technique for the manufacturing anomaly detection model that we built. But the exact same type of model can be used in a very wide variety of scenarios, including medical billing anomalies that we've used, and it's not just medical billing, but that's a scenario that we've actually done work with. Fraud detection is a very popular scenario for most businesses, and so even though I haven't listed financial services, it's certainly a wide variety of businesses could look into that. But also, outside of the sort of front office pieces, from a back office perspective, if you have a lot of servers, you can use this approach in order to be able to understand the types of servers and their type of usage patterns so that you can have a better understanding of what their needs are and be able to do better planning there. And for those of you who may have development that you're doing in applications, building complex web searches is an interesting approach where you could potentially if you have a very large data set, be able to build a cluster for a very wide number of columns and then use that to be able to partition data so that it's quicker to find things based on this lookup to a particular segment that you would look at there. So again, we have a one type of model that can be used in a wide variety of use cases and in a wide variety of applications. So last, we'll move to retail. And in retail, one of the challenges is that we have generalized content. We also, without having a lot of understanding of the customers, it may be hard to be able to reach them and to be able to tailor messages. So, we want to certainly be able to embrace the technology as best as we can in order to be able to move forward in being able to get better sales from those customers there. Sorry. So when we look at supercharging retail, we want to take our existing data and join it with other sources, ideally. But in general, that's not something that's specific to retail. But predictive analytics is a great way of being able to leverage your existing investment not only in any data collection you've done, but also in any business intelligence skills that you've developed, because a lot of the work that you do is very similar in order to be able to prepare for building these models. And through that work, you'll be able to eliminate guesswork, gauge customer responses, and also be able to have a much better response rate by being able to tailor messages for those customers. So what I'm going to show you here is an example of a different type of algorithm that is an associative one, or a market basket analysis, if you will. So what I've done here is that you can see that we have item sets, or you could look at as bundles of products that were sold. So what I'm doing is a search to see. So for mountain bikes, we can see that for this particular group of customers, that there's a common bundling of fender sets and hydration packs. But if we look at a different customer segment and we look at the same product, we end up seeing very different patterns. So you can see there that their main, the main bundle that you see is with a mountain tire there. So the idea is that if you're building a recommendation system, you want to make sure that you understand first the differences in the personas of your customers, and also make sure that when you're making recommendations that you're using that same type of information. So as a particular example here, we have a cluster that we've associated with a particular customer that is on the website, and then we also have here recommendations that have been tailored for that particular customer as well. So this approach with using association and market basket analysis is one component of a larger recommendation engine system that you may be looking at. So, but generally speaking, you want to start with looking at segmentation to understand your customer profiles, because a lot of times you'll be looking at a longer lead time for marketing collateral and customizing messages. But then also use that as an input to be able to not only understand different buying patterns based on that filtering, but also once you understand those relationships, start to build other models similar to the product propensity ones we saw in financial services in order to understand what factors are involved in those decisions and how likely they are in order to be able to do a particular purchase. So from a modeling perspective, this can end up becoming, a little bit of work to put them together, but we certainly take a lot of the labor out of that there. And then when you are doing model consumption in your applications, you want to make sure that you're bringing all three of those together in a similar order in order to be able to move forward there. So beyond retail, recommendation engines are wrong slide. Yeah. So the let me go back here. So beyond recommendation engines, we may look at association algorithms for a wide variety of applications. You could look at it as a way to be able to break down what might be the next procedure that a patient needs. One of the common scenarios that we've used it for is also to look at optimizing for supplies and purchases, because if you can find out products that are frequently purchased together, then you can try to plan your orders together because you may be able to get a discount on those larger scenarios. And you also can use it, I've used it with customers in helping for large customer tech support groups in order to be able to look at events that come in to see if there's a relationship between, you know, a particular type of application being installed and a particular service call that need to happen for that particular machine itself. So again, you have a very wide variety of applications that you can use these for. And with that, I will turn it back over to Jamie for closing remarks and questions. And again, I thank you very much.
Jamie, are you with us?
I think Jamie needs to be unmuted on your end, Jennifer.
He is.
Interesting. Okay, well, we're in the same room. Let me see if I can. Okay, so he's working on it right now.
Hello, everybody. Hello, everybody.
There we go.
Thanks, Drew, for going through those use cases. Now, with Prediction Insight, we offer, I would say, a very compelling offering for creating predictive apps and supercharging your apps through predictive analytics. Our goal is to make predictive analytics a process and technology which is accessible to all comers, to all users. And we do that on many fronts. First, we try and very hard to make it very easy to create the models which Drew demonstrated in his use cases. And we do that by adopting familiar concepts and familiar tools such as Microsoft Excel in a very complex environment, bringing Microsoft Excel to the forefront in creating predictive analytic models using BI concepts. So you can take the concepts you know, the analytical concepts you know, and adopt those to create predictive analytics models in ways that are much easier than have been previously. We've created a set of collaboration tools which allows you to interact with other people and get buy-in from a large number of people on a predictive analytic environment, so you can actually see and understand what you're working with and what you're talking about on a predictive platform that really hasn't been done before. And then as far as how applications happen, is we've really made it possible and simple to deploy predictive models into working environments. We have a simple non-blocking publishing mechanism that allows you to take the models that you work with, publish those out into shared collections where they're immediately consumable by application without having to bring any systems down or having to bring any new systems up. It's all done inside the same environment. They're integrated. The models are automatically integrated with major ETL and database frameworks so that you can pull data from any source, assemble the data, and push it to our service, or pull data into our service from any databases into ETL frameworks and take those results and put them where they need to go to have the greatest values. And finally, we've wrapped our entire Prediction Insight service in web services APIs that allow you to access them from any application. So I can write mobile applications, I can write .NET C# applications, thin client Java applications, all using The model is created through an Excel environment integrated with your database backends in a complete package, which allows you to deploy and create those predictive analytic applications very quickly and seamlessly. So I'd like to turn it over to the last slide and turn over to Jennifer, and we'll take any follow-up questions to close out our webinar. And thank you for everybody who's spent the time with us today.
Yes, thank you so much, Jamie and Drew. That was great today. There are a few questions that have come in through the question pane, and for those of you that do have questions that haven't sent them in yet, please take this opportunity to do it so we can answer them live for you. So let's see. The first question I have is, what's the minimum data volume one needs to make this work? Can you take that question, Jamie? Hello? Can you hear me now? Okay. Must be a delay on my audio. I apologize for that. So did you hear anything at all that I was saying, Jamie?
I did not.
Okay, sorry about that, everyone. Again, I wanted to thank you all for attending. That was a great job, Jamie and Drew. And we do have some questions to go through. If you haven't submitted any questions yet, please do so now so we can answer them for you live. And let's see, the first question I have here is, what's the minimum data volume one needs to make this work?
The minimum data volume is actually a tricky question because there isn't necessarily a minimum data volume for any particular question. We have developed different predictive applications with data volumes as low as a few hundred rows of data. For example, if you're doing a forecasting model and you had 10 years of data by month, that would only be 120 rows of data, and that would be fine for that kind of problem. If you're looking at more of a application like Drew was explaining, where you're looking for manufacturing defects, or if you're looking at interactions between products, your data volume has to be somewhat relative to your data complexity. So the more fields you have, the more data you need. Most situations I've seen, if you only have 10,000 rows of data, that's enough to build an initial model. You get over to 100,000 rows of data, that might be even better. But eventually you get to the point where you're not going to learn more by having more data. So on a rule of thumb, between 10,000 and 100,000 rows of data cases, it's probably enough.
All right, thank you, Jamie. The next question I have here is, does this perform time series forecasting models via web services?
Yes, it does. Everything that we can do with any of the tools that we have, any of our client tools, which is our Excel client or our thin client visualization, can be performed through our API. So all of our product we have a client piece and we have the service piece, and everything is accessible through our web services API.
Okay, and next we have a question. Can the results of a prediction be integrated into a CRM system like Dynamics, for example?
Definitely. We have actually a sample application that we built ourselves, which will take the results of predictions and push them directly into Dynamics CRM. And we also are soon to release the ability to perform the predictions directly in the CRM databases without having to move the data out. So you can actually push the models and publish the models directly to your database sources and have those operate into your applications. In an application like CRM, kind of as I was talking at the beginning about your Power Bill application, you would present those results in a way that makes more sense to that individual user. For example, rather than having a general campaign that you apply to every customer, you could say which campaign is each customer most likely to respond to, and have individualized results for each customer, which will make you take more actionable results with better responses.
Okay, thank you. Next, here's a question. As a developer, is there any way to play or experiment with the API that you've mentioned? Is it available? I'm having a hard time reading this, at a particular website by any chance?
It's not available on any particular website. We are working on getting our API documentation completed, and we are also looking at ways to release the product in a way for a developer edition where any user can come, developers can go and actually use the API in their own environment.
Wonderful. Another question here. We've got lots of questions today. This is great. How do you validate the accuracy of your predictions to ensure confidence in the results?
We have a whole suite of accuracy validation tools, such as lift charts, cumulative gain charts, ROC charts, classification matrices, where you can bring in test data, or we can automatically hold out test data when you build the model to validate the accuracy through a variety of different metrics across many models simultaneously. And what's interesting about our accuracy validation is that due to the different types of problems that people are solving, different accuracy measures are important for different people. We have included all of the accuracy and validation facilities into our thin client environment, collaborative environment, so it makes it very easy to share, even just via email, access to the accuracy measures in an interactive fashion, so you can collaborate with your colleagues to make sure that you're getting the best models using our tool.
Excellent. Another question here is, how is the server licensed?
How is the server licensed? We have a variety of licensing methods, and I think it's more of a kind of generally an offline kind of question. But in general, we have our web application, our web service, public cloud service, where you can go and sign up today and sign up for our public cloud service. We also have perpetual and subscription licensing options for our server.
Perfect. And then, is there a limit to the maximum amount of data that Prediction can handle?
Is there a limit to the maximum amount of data? That's also it's almost as difficult a question to answer as what is the minimum amount of data that you need. I would say that there's typically a built-in limit to the maximum amount of data Prediction can handle, and there's also the issue of whether or not you're handling data for creating new predictions or for building models. Typically, there's a limit in the maximum amount of data for building models. It's more based on how much time do you want to spend crunching the data versus how much time do you want to spend consuming the data. As far as usually the larger data volumes come in when you want to consume the models to create predictions, and in that case there's absolutely no limit because we don't retain the data in order to perform those predictions. So if you have 100 million rows of data, we don't store that 100 million rows of data. We just perform the prediction on every individual case and then return the result to you. So there is no limit there.
Okay. It looks like we're just about coming up on the end of our hour here. There's one more question. I'm evaluating a healthcare use case where I'm looking to deploy the results to a clinician, perhaps in a mobile type application. Do you have any experience here?
Yes, we actually do. We have developed applications for clinicians, or sample applications for clinicians, where the presentation is presented on an iPad using a web services solution which communicates with Prediction. So we understand that the visualizations that we put together, although we love them dearly and they're very beautiful and pretty to use, they're not suitable for every end user who's going to be using our situation, using our product. So all of the information which goes into those visualizations is available through our web services API and can be easily deployed into any BI framework, any dashboard framework via our API or ODBC connections, or you can take the predictions one prediction at a time through as Drew showed, through Stream Insight, even to bring the results to the output mechanism of your choice, such as an iPad or an iPhone.
Okay. Well, thank you. We're just about out of time here, folks. So if you do have additional questions, don't hesitate to email them in, and we can answer those offline, and we'll be happy to provide any responses that you might need. So we hope you've enjoyed the session today, and we'll take some time to explore Prediction Insight with our free 30-day trial that's available on our website. And we look forward to having you back with us on October 9th when we have another webinar presentation by Dr. Mercy, and he's going to be looking at solutions to reduce readmissions, hospital readmissions, and what to look for in choosing a technology solution to solve that problem. So watch your email. We'll send you an invitation to that event and hope you can join us again soon. Thank you so much.
Thank you, Jennifer.
Thank you, Jamie and Drew.
Bye-bye.
Goodbye, everyone. Thanks for joining us. And we'll have a replay online for your colleagues that you can share. We'll send a link out to that as well. Have a great day.